Stop.
हाँ लाइव गो लाइव तो कर दिया मैंने। हाँ हाँ
Karthik, start.
I can start.
Right.
I think Subhash has to present.
Subhash is
live?
presenting. Actually, he's live. Yeah, you can start.
Okay, okay. Hello. Those of you who are here, heartily welcome to all of you to FrostHack 2021. So currently, I have with me the organizers, me, Karthik, Subhash is here, and Saransh is here as well. So and also Shomo from from the Tezos team. So what we'll do here is we'll basically give you an introduction to blockchain, and most of you might not know about Tezos. So Shomo will give you here an introduction to Tezos as well. We have a special bounty for Tezos for the best Dapp app build. You can check out those on our website. So yeah, so basically Shomo will carry on from here and give you an introduction about blockchain and Tezos as well. So yeah, let's Shomo, can you carry on from here?
Sure. Thank you, Karthik.
Okay.
So in today's workshop, where I'll just give a quick overview of what we're going to cover. Right? So first of all, I'll talk about blockchain. Right? What is blockchain? What it does and why is it needed? Then I'll talk about Tezos, and then finally we'll have a hands-on demo of writing actual decentralized application that runs on the blockchain itself. So without further ado, let's jump in. So first of all, the first question that might come to your mind is, for those who do not know what a blockchain is, right? What is this blockchain, right? Recently there has been some, fuss about Bitcoin and Ethereum and those things, right? So let's talk about blockchain first. So if you search the term blockchain on Google or in any place, right, you probably get a technical definition like this, right? A blockchain is an immutable, decentralized, distributed ledger. So there are a lot of jargons here, right? So let's try to dissect each word and each term and see what it actually means, right? So let's start with the simplest term in this, ledger, right? So a ledger is basically a record of transactions, right? So in real world, you can see businesses maintaining logbooks or records of all the transactions that happen in the day-to-day business, right? So a ledger is basically that, and a blockchain is basically a storage for this ledger of transactions that are happening on the network, on the blockchain network itself, right? So you might be thinking like, okay, so it's a ledger, right? So blockchain is a ledger. That means it's storing data, right? So it's a database or something like that. It's kind of like a database, as in like it stores the state or the data of the transactions. But on contrary from normal databases or normal systems, blockchain is decentralized and distributed. So what does that mean, right? So a blockchain network is composed of different of multiple network participants or nodes, right? So this is basically a peer-to-peer network that is handling these transactions that are happening, right? And these transactions, like this ledger that I was talking about, right, is not just stored in a single central storage. It's not there in a single server that is holding this complete ledger, right? It is actually distributed over each of these nodes in the network. So that is why it is called a distributed network, right? And decentralized in the sense like each of these transactions, right? So you can think of a transaction with a real world, scenario, like I am sending X amount of money to someone, right? So that is a transaction, and in blockchain also that is exactly how it is, right? A transaction is like one address sends some amount of asset or tokens to some other address, right? So that is a transaction in the blockchain world. So these transactions, right, are being stored on the ledger, but who determines whether a transaction is valid enough to be stored in the network, right? So this consensus, right, this decision of whether a transaction is valid to be stored in the blockchain is decided by the network participants itself. So there is no single authority which can decide decide this. So there is a complete decentralization. So there is no centralization in this network. So all parties that are there in the network are actively taking part into the governance of this network, basically. So that is what decentralization means. To visualize how a blockchain looks, you can look at this diagram that is here, right? It's a little bit hazy, but if you can look at, if you can see, there are blocks. As you can see, there are 3 blocks here, and each block has some data, right? So apart from the metadata, there is one main thing that each block is holding. That's a transaction. So this is a transaction that I was talking about, right? A sending B X amount of money, right? So that is a transaction. So that transaction is actually being stored in this block, and these blocks are like, there are multiple blocks in this chain. So you can see that each block is connected with the next block and the previous block with their hash of previous block and hash of current block, right? So that is how each of these blocks are connected with one another, forming a chain. So that is how the name comes here, blockchain. So how are these blocks created, right? So there are different mechanisms depending on the net chain that we are talking about, depending on the blockchain that we're talking about. So there are different types of blockchains. So some popular blockchains that we know of, right? Bitcoin, Ethereum, Tezos, right? So some of them, each of them work on different principles, right? So Bitcoin works on a consensus algorithm called proof of work, which is basically like, there are network participants who are constantly solving cryptographical puzzles, right? So these cryptographical puzzles are proof that the transaction that is being added to the blockchain is valid, right? So that is what they are trying to do, and all the network participants are competing to get the next valid proof. And once they find the valid proof, a new block is generated and created, attached to the existing chain. So that is how the blocks are created on Bitcoin. On some other network like Ethereum 2.0 or Tezos, which is based on proof of stake consensus algorithm, there are some dedicated validators who have staked some large amount of asset of their own. So that is how they are proving that they have authority to mine these blocks, right? So these validators are then collecting these transactions that are happening on the network and then creating these blocks. So that was a quick overview of how a blockchain, what a blockchain is and how a blockchain works. Now the question is, why do we need blockchain, right? Why can't we just use our existing systems, right? We have so some existing systems might be normal banking systems, social networks. So all these are centralized systems, right? So why can't we just use those, and why do we want to move to blockchain? So the first reason is blockchain is decentralized, right? So by decentralization, we mean that there is no single authority who can govern the system. So in case of, let's say, a bank, right? Today you are doing a transaction, and the transaction goes to the bank server, and then the bank server validates the transaction, and then it does the actual asset transfer, right? So the complete authority of validating the transaction, whether whether they want to approve the transaction or reject the transaction, depends on the bank server itself. So the bank has complete authority of that, right? So if they want, they can reject a transaction anytime they want, right? So that is the problem with centralization. So with centralization, you can have censorship, you can have trust issues coming in, right? So you have to have complete faith on a single authority to do a particular use the system, right? But in a decentralized system, there is no such single authority, and the consensus, like the decisions of the network, are made through a consensus of all the participants in the network. So that is the main feature of a blockchain, right? So there is no possible way of censoring your censoring your data or the transactions, right? So for example, on Twitter, right, if you post something and if it is deemed inappropriate, then it will be censored by Twitter, right? So they can do it because they have the central authority of the whole system, right? but in a decentralized system, there is no one who can do that. So these are the features of why blockchain might be useful in some systems. Apart from that, obviously, blockchain has another feature of immutability. So that means that anything that is included in a blockchain, so let's say I do a transaction today, I am sending X amount of money to someone, right? So that is being recorded in the blockchain, and there is no way that someone can alter that particular transaction, right? In case of a normal bank transaction, right, the record of the transaction is actually stored in the bank server. So in case the bank server is compromised by some attacker or something, right, then they can easily change the record in the database, and that will cause problems, right? But in a blockchain system, that does not happen, and it is very difficult to actually change transactions that have been included in the blockchain itself. So these are the features of blockchain. So moving on to decentralized applications, right? So blockchain itself, like Bitcoin, right? A blockchain network like Bitcoin, which was mostly used for asset transfer. You send X amount of money to someone, and someone sends Y amount of money to someone else. That is what the first use case of blockchain was. But nowadays, we want to build applications on top of blockchains, right? These principles of blockchain, right? Immutability, decentralization, distributed system, right? So we want to build on top of these features and use them into our applications itself. So that is where decentralized applications come in, and blockchains like Ethereum, Tezos, all these blockchains allow you to write applications and leverage the features of the underlying blockchain itself and use that as a basis for your application. So decentralized applications, as you can see, are digital applications or programs that exist and run on the blockchain or the P2P network of computers instead of a single computer, and are outside the purview and control of a single authority. So that is basically the feature of blockchain. So the application that is going to be deployed on the blockchain is going to have all the properties of the usual properties of the blockchain itself. Some of the examples of existing application, decentralized applications, popular decentralized applications include games, collectibles, or NFTs, right? You must have heard of NFTs right now. They're pretty popular right now. So that is that is rising currently very much. So NFTs, collectibles are basically the NFTs. Then DeFi, or decentralized finance. So there are platforms on Compound, like on Ethereum and Tezos also, which allow you to move from the centralized financing system that is there, like, you submit, you escrow your funds in a bank account, right, and you incur some interest on that. But what you can do is you can do the same thing now on the blockchain by escrowing your blockchain assets or tokens into a particular decentralized application that is going to provide you the interest for that particular amount that you have to escrow. So these are the common popular applications that you can see right now. So the question might arise then, like, how do we build it, right? Like, how do we program applications that run on blockchains? And the solution to that is a smart contract, right? So a smart contract is basically a script that you write, a program that you write to run your application or to run a particular logic on the blockchain itself, right? So as you can see, a script stored on a blockchain so a smart contract is a script stored on a blockchain that enables users to define custom rules and protocols for various purposes. Some of the typical examples include escrow accounts, insurance-like contracts, decentralized applications like I talked about, DeFi, NFTs, and stuff like that, or simple multi-signature or multi-sig contracts and security tokens and stuff like that. So all of those applications that you see right now on different blockchains like Ethereum, Tezos, or some other smart contract enabled blockchains are all written in this using the smart contract language that is supported by the particular blockchain. So yeah, so that was a basic overview of all the features, or most of the features of the blockchain. Now let's talk a little bit about Tezos, which is what we are going to use today to build our application. So what is Tezos, right? So Tezos is a a blockchain network, just like Bitcoin or Ethereum, and it has the native currency as XTZ. So a cryptocurrency XTZ which enables borderless transactions, transaction capabilities, and smart contracts. So you can write these decentralized applications and deploy them on the Tezos network. It is basically a programmable money which removes the need of the middleman. Like I said, so that is the first principle of blockchain, right? There is no central authority that is governing your transactions or anything. So it's completely decentralized and peer-to-peer. What is the main feature of Tezos? Like, what is it different? What it does different from the other blockchains that are there? So Tezos is basically uh, it basically has the self-amendment capabilities using the on-chain governance, and provides a formally verifiable smart contract. So um, what it means that when there is an upgrade, right, when you need to upgrade the protocol for, let's say, the network protocol, then you can have an on-chain governance process where all the validators on all the network participants basically vote on that, and the network will automatically upgrade without having to hard fork or do anything like that. So on other chains like Ethereum, you usually have to do a hard fork if you are going to upgrade to a different protocol, or you have to make some upgrades in the network protocol itself. So that is not required in Tezos. And another big benefit of Tezos is that the smart contracts that you write are formally verified. So it is basically statically checked before you deploy the contract. So that kind of reduces the chances of having any errors that might creep into your code. But still, the logical errors will not be out. That is still something that you have to look out for while you're coding the smart contract. Tezos works on proof of stake, like I said previously, but the difference between Tezos proof of stake and a normal proof of stake algorithm is that Tezos follows something called a liquid proof of stake, which is particularly different from another form of proof of stake called delegated proof of stake. In delegated proof of stake, what happens is that you have to basically delegate or lock up your funds when you are, going to delegate it to some validator, right? But in case of Tezos, you do not have to actually transfer the ownership of your tokens. So even though you are delegating your tokens, you're not actually locking it up with the particular validator. So you have complete access or control over the token, so you can use it anytime you want. So that is why it is called liquid, because your asset is still liquid in that format. So that is why it's called liquid proof of stake. How do you write smart contracts in Tezos? So all networks, right? Like, for example, Ethereum has a smart contract language called Solidity. There's also something called Viper on Ethereum. But on Tezos, what we focus mainly is SmartPy. That is one of the most popular smart contract languages right now being used on Tezos. There are other languages, obviously, like Legolang or Michelson, that is a low-level language. But SmartPy has some features that makes the life of developers very, very easy. And that is what we are going to do today. So we are going to use SmartPy to write the smart contracts and create an application. So as the name suggests, SmartPy is a contract language that is based on Python itself. So if SmartPy is a Python library for constructing Tezos smart contracts. It comes with a compiler that generates the Michelson code. So SmartPy is basically a high-level language that helps the developer to write the smart contract, but at the end of the day, when you compile the code, right, it is compiled down to Michelson, which is the language that is understood by the blockchain, by Tezos. Right? So the benefits of using SmartPy is that it is because it is based on Python, right? So you have the features of Python itself. It's intuitive, it's effective, and those of you who have already learned Python, it will be very easy for you to pick up SmartPy. And for those who do not know Python, it should still be easy, because Python itself is a very easy language to pick up. Moving on, SmartPy. So like I said, so being a Python library means that by defining smart contracts, users benefit from the full power of Python. So you're basically writing Python syntax or very similar syntax to Python to iterate over the data structures, call other libraries, pre-compute parameters, and all those features that come with Python are also packaged into SmartPy itself. So it should be pretty easy to pick up. Talking about some developer tools. So first of all, smartpy.io/ide is where you can start coding your smart contract. So if you have experience with Ethereum, you know that there's something called Remix, which is a in-browser editor for Solidity and Python. So SmartPy io/ide is the browser editor for SmartPy. So you can write your code there, test it, and even deploy it from there. So I'll show you how you can do that soon in the code walkthrough. Then we have Cryptoverse Wars, which is basically interactive game kind of tutorial where you can play where you are basically writing code and learning SmartPy and Tezos specific uh, tools and technologies, and it makes learning the whole like all the technologies that are required to build on top of Tezos very simple. So you can go ahead and try that if you want. Other tools include obviously the SmartPy IDE, the wallet extension, Thanos. So we'll be using Thanos today. So a wallet is basically how you connect to the blockchain network. So basically, if you are going to make any transaction or make a contract call in that sense, you have to use a wallet. So that is why a wallet is required, and we'll be using Thanos today. There are other wallets like Galleon or Kukai. So there are different wallets that you can look into, but Thanos is pretty simple to use, and you can just install it as a browser plugin, and it'll work out of the box. Developer super packs, tester GUI, tester CLI, bundle React. So these are all pre-packaged tools that you can use, or packages that you can use to ease your development. So you can use bundle React, which comes in with all the required prerequisites for connecting to the network and those things, and start up your front-end development directly without having to install other dependencies. So you can use that. Tester CLI and GUI, you can use it for interacting with the blockchain, seeing transactions and those things. So that helps you in your development. Explorers and indexers. There are many explorers and indexers out there, but the popular ones include Better Call Dev and tzkt.io. So indexers are basically how you can look at a transaction that you have made and see the status of the transaction. If you're making a contract call, you'll see the contract call data and the storage change on the blockchain, and those things are visible through an indexer. They also provide APIs if you want to use them in your application. So sometimes you need to use an indexer, because directly interacting with the blockchain is not always that fast. So you might want to use an API that is provided by these indexers to make quick calls and quick queries. So that was the tool. For materials, that is the client-side libraries and the language that we're using for our contract. So for the contract, we're using SmartPy. For the client-side libraries, we have a few options. So if you're having a server-side application, or some application that is running Python, you can use PyTezos. If you're doing front-end development or front-end Dapp development, that is if you're writing something that is going to interact from the browser, you can use Tuckito or Console.js. Both of them actually work in Node.js too. So if you have a server that is running in Node.js, you can also use those at that time. Developer support. So the first thing to make sure while you are starting off with Tezos is that you join these channels and start asking questions. So the more you ask questions, the more you can learn. So basically, these are the resources which you can follow up. So developers.tezos.com is a website where you can find Tezos related details and other resources related to Tezos. Then you have the SmartPy reference, which is basically a documentation for the SmartPy language. Crypto Code School, which I've already talked about. Tezos Stack Exchange is where
Shomo, sorry to interrupt. There is a question. Can I tell you?
Yeah, sure.
Yeah. So it's question. The question is basically to write smart contacts in Tezos. We need to know Python.
Like there are different smart contracting languages, like smart contract languages like SmartPy, Nego. So if you want to do SmartPy, then you might need to know a little bit of Python. It's pretty simple. Like I'll show you how you can write the code. So I don't think that will be too difficult. Even if you do not know Python, you can quickly understand the syntax and get started by looking at the examples that are there. So that should be pretty simple.
Okay. I think it's clear there.
Okay. I was talking about Tezos Stack Exchange. So basically, if you have any questions, right, you can post it on the Tezos Stack Exchange, and someone will probably answer it, or you can find some existing questions that might match your query. So you can get the solution from there. If you have anything specific to SmartPy, then you can join the Telegram channel of SmartPy.io. And if you are developing on Tezos, do join the India Tezos developer group on Telegram. There's a pretty good support available there, so you can post your queries and someone from the community will reply back to you. Apart from that, there are docs and for the client library and the contract languages, like I said, so you can take a look at these docs, whichever library you're using, and get started. So that was all for the presentation. Now let's move on to the actual application development, right? Dapp application. So first of all, before you start developing the Dapp, you need to have a account or a wallet, right, to connect to the network. So for that, we'll be using Thanos or Temple wallet in this case. So it's the same wallet. They just changed the names recently. So you can download it, and it's a browser extension, like I said. So it's available for Firefox, Mozilla Firefox, or Google Chrome or Brave, whichever browser you're using. So you can download it and connect your wallet here. So you can see that my wallet is present here, and I have already created an account, but I'll still show you how you can create an account for yourself. So to start off, you'll probably need some Tezos to do the transactions and those things, right? So how do you get the transaction? You get this testnet Tezos, right? So right now I'm the Florence testnet, as you can see. So I'll go ahead and click on import account, and that opens up this option. Here I can go for faucet file, and here you can see if it's visible. Let me just go to this tab, that is better. Yeah, so this is the same wallet extension, just to see the full screen. So I'll go back to import account and then faucet file, and here we can see that there's a link to faucet.tz alpha net. So we can just click on that, and it's going to take us to this page. We can just verify. Just quickly verify, and then get testnet tz. So it gives us this JSON text. We can just copy it over and paste it here in faucet JSON, and then submit. So this is basically creating your account on the testnet. So I'm on the Florence testnet right now. So it's going to create an account. So it takes some time, as you can see, to approve, like to create the account and reveal the account and those things. So it might take some time. So you have to wait a few more seconds, and then your account should be visible here with the testnet balance, right, like here. You can see the testnet balance which you have. So yeah, so the account is live, as you can see. So this is a new account that came up, and this is the testnet assets that you find here. So I already have some accounts that are there on the testnet, so I'll be using these for the demo. So once you have the account, the next thing that you need to do is write the smart contract. So yeah. So to start off, this is the SmartPy ID that I was talking about. So this is the browser ID where you can just go in and start writing your code, and you can test it here and deploy it directly from the website. So I'll do those things later on. First, let's start writing the contract. So to start off, we need to first import SmartPy, right? So like I said, so SmartPy is basically Python. This is basically a wrapper around Python itself. So the syntax will seem very similar to your usual Python syntax. So let me just import the SmartPy package.
Hello.
So once you import the SmartPy package,
Hello.
you can start writing your actual contract code. So to write the contract, we are basically going to create a Python class that is going to import something called the SmartPy contract from the SmartPy package, right? So let me just class,
ना ना मेरे से नहीं होता। कोई देखो जो अनम्यूट है वो देखो मेरे से कैसे
and
आएगी
then
मैं बल्ले बल्ले म्यूट ही कर। नहीं नहीं मैंने
so this
मैं
is
स्ट्रीम में वो
basically
नहीं चला रहा, मैं
telling
जैसे
the
यूट्यूब पे कुछ
SmartPy
देख रहा
compiler
था।
that this is not a normal Python class, but this is a
ना ना बस सही
Tezos
है।
contract class. So when it's going to compile, it's going to compile the code as a
नहीं मैं तो
smart
यूट्यूब
contract
पे
code,
एक तो
basically.
स्ट्रीम भी देख रहा हूँ
So
ऐसे और बीच बीच में कुछ
so
ऐसे आ या
the
गया
thing that we're going to
स्टोरीज देख रहा हूँ स्ट्रेस
write today, the application that we
अब
are
आ
going to
रही है
write
क्या?
today is basically a simple storage Dapp. So this is like the hello world program for you know, decentralized applications.
अभी चेक
So
कर।
basically the task or the goal here is to write a contract that is going to take a value and it's
कौन?
going to store the value in the
नहीं
blockchain, and you can then retrieve the value on the front end, change the value, update the value, and those things, right? So that is the goal. So to start off with the contract
वो भाई
itself,
कहाँ से आ रही है
after
आवाज?
you have declared the class, you have to write the uh, constructor, right? So let's just write the constructor.
अभी भी आ रही है क्या?
And then so when you're in the constructor, you have to actually initialize the storage of the contract, the initial storage, how the initial storage will look like. So to do that, you have to call self.init, and then you can add in your variables or data that you want to store on the blockchain itself. So anything that you include in this block is going to be stored on the blockchain. So it is the state of the contract kind of. So for example, here I'll just create a variable called stored value, and I want this value to be equal to the value that I'm passing to the constructor. So I'll just convert it to So what I've done is basically I've initialized the storage
हेलो
with a single integer value, as you can see
कहाँ से आ
sp.2.
रही है आवाज?
I'm typecasting
अभी
the
आ रही है।
value that I'm providing here to integer, and I'm storing the value in the contract storage here. So that is the value I'm going to use. Now I can start writing the entry points basically. So these entry points are what we are going to call when we're interacting with the contract, right? So to declare an entry point, we have to write a decorator first, sp.entry point. So this decorator is going to inform the compiler that this is not a normal function, but a smart, like a contract entry point itself. And then we can just write, let's say, update, and just like any normal method in a Python, we'll have to write self and then the parameters that we're going to send over. So in this case, I'm going to send object basically here, which is going to have a particular key called so in this case the parameter that you can see here, right, is basically the input to the entry point. So when you're calling the entry point from your uh, front end application or the UI or the client application, you have to send that particular parameter. So in this case, I'm sending it as a object, but you can also just send a single value. So I can just write params also. That would also work, but it's smart, right? So smart params at value, and now we want to store this particular value into our storage, right? So we want to update the previously stored value with the value that we're sending here, right? So what we'll do is like we'll go for self dot data dot stored value. So this line here is basically pointing to our storage that we had created here, initialized here, right? So the variable stored value can be accessed using self.data dot and then the name of the variable that you have used for the storage. That way we can access the values in the storage that we have stored, and we can to update the value we just write it like uh, self.data or stored value equal to parameter value. So this is going to update the data that is stored in the storage with the coming incoming data from the entry point here. So that was a simple entry point for you. So you can now have other complex operations that you want to do. Let's say, for example, in this demo, we'll try to do some arithmetic operations. So let's say I want to write an entry point that is going to multiply my storage value with some new value, right? So let's just create a function method that will take again params, and that's going to update the stored storage value data stored value, and just like we do in Python we can write like this and params dot value. So this here is as a syntax suggests, we are basically taking the params dot value that is being sent over for the entry point, and we are multiplying that to the storage value in the storage and just updating the stored value with the resultant of that multiplication. So as you can see, this is very similar to what a normal Python function would do, or Python syntax looks like, right? So you can basically do anything, almost anything that you are accustomed with in Python. So let's just create one more function and then we can test it out. So I'll also create a function that will add two numbers with the storage. So let's say self.data.stored value, and then so right now I'm going to pass two values to the entry point, right? And because params is an object itself, we can just write it as like this: params dot a plus params dot b. So when we are calling the add entry point, we have to send two inputs with the in the object. So we are sending params.a and params.b as the input here, and as the operation suggests, we are just adding these two numbers and adding it to the value that is stored in the storage and updating the storage again. So that is all for writing a simple entry point, right? You can add in more complex logic. There are if conditions and things like that that you can do. So I'll just go ahead, click on this. Reference. So if you want to learn more about what you can do with SmartPy, you can look at the reference. So this is the reference, SmartPy reference, and here you can see the other functionalities that are there in SmartPy. So you can do if conditions, conditionals, you can do loops, you can call other contracts from the contract that you're writing right now, and all those features are available. So you can just go through the SmartPy reference and see those functionalities that are required for your use case and use them accordingly. So coming back to the editor. So now that we have written the contract, right? So we need to test it out. So here's a play button that we can run. So that is saying we can run the code. So this is going to actually simulate the network and just going to just run the code as it is in the browser. So it's going to run the tests also. So if I go ahead and run the code, it's going to throw me an error right now and say that that there is no tests specified here. So what I'm going to do is I'm going to add the tests. So let me just copy over. So I've already created the tests and kept it here. So I'll just copy it over. So this is the test side of the thing. So to actually test your contract here, you have to um, add something called a test, add sp.add test, and then write a function that is going to basically create a class, create an object of the contract class that you've written, and then it's going to call the functions and basically verify that the contract is working as expected. And there, it is very important that you make sure that you test your contracts before deploying, because once you deploy your contract to the blockchain, it is immutable, because you cannot change anything in the blockchain, right? So even the code that you have written is going to be uh, immutable in the sense that you won't be able to change it anymore without redeploying the contract. So you'll get a different contract address. So make sure that you test your contracts before deploying. So now that I've added the tests, I can just quickly go ahead and compile and run the code. So I'll just go ahead and run. And if I click on side by side, yeah, I should see the see something like this. So this is how the editor is displaying the tests that you have written here. So for example, this is the SmartPy, actual SmartPy contract that I've written. It's going to talk about the storage value that is there. So in this case, right, in the test, as you can see, I'm initializing the storage contract with the value of 12. So that is the value that is there in the contract at the very beginning. So you can see that, you can see the entry points that are there. So this is basically the contract itself and the balance and the contract address and everything. Then comes the transaction that we're doing. So we are making some calls to the contract. So here we are calling the update function. So it is going to update the value to 15. So here we are sending update call, entry point call, and we're sending the value 15, and we can see that a stored value in the contract has also updated to 15. And similarly for other entry points like multiply, we can send value equal to 2, and we should see that value is 2, and this is being multiplied with the value stored in the contract, and the value has become 50 because the previous value was 25 after the next update. And similarly, we can do other operations, and we can check the values also to verify whether the the storage value and the data that you're expecting matches. We can do something like scenario dot verify, which is basically a way of verifying the value. So if you've written tests in JavaScript or some other language, you have seen this kind of syntax before. You're basically verifying two values match or not. So this is what it is doing here. So we are matching whether stored value matches 50, and then we are doing an addition operation and calling the addition entry point, and then checking whether the stored value is updated to 39 or not. So that is all for the testing part. Now that we have the contract and we have tested the contract, what we can do is deploy the contract, right? So to deploy the contract, you can either use your own scripts, custom scripts. So if you want to automate the process of deployment, right? If you do not want to manually do the deployment, you can write some script, and that will automatically deploy the contract for you. But for now, for the sake of the demo, I'll just go ahead and use SmartPy itself, the SmartPy IO website, and go ahead and click on deploy Michelson contract, and then click on deploy Michelson contract again. So that is going to take me to another page where I can choose the network where I want to deploy the contract. So in this case, I'm going to choose FlorenceNet, which is the one that that is a testnet that I'm using right now. So there are other testnets available like Elonet and GAlphaNet. You can use those if you want, but for now I'll be using FlorenceNet. And then you can connect your wallet. So there are different options to connect the wallet. So I'm using Temple or Thanos wallet. So here I can click on Temple, and that will pop up the wallet, and we can select the account. Let's say I'm going to connect this account, and it's going to say that account has loaded. And once the account is loaded, you can estimate the gas and fees required to deploy the contract and finally deploy the contract. Also, if you want to customize the storage, so right here you can see that the storage here, initial storage is set to 12. But let's say I do not want to set the initial value to 12 but to 0. I can click on edit and then change the value and save it, and that will update the storage, initial storage. And finally, after you're done with the changes, you can just deploy the contract. Accept. Another wallet will pop up and you just have to accept the transaction, sign the transactions basically, and accept it. So the contract has been successfully originated, as you can see, and this is the contract address. So a contract address is basically similar to an account address on a blockchain network. The only difference is that you can make specific function calls or entry point calls on these accounts and do stuff with it. Right? So this is the contract address, and we can actually see it in the indexer. If you want, let me just open protocol dev. So let me just go back. So I just search for the contract, and you can see that the contract has been originated in the Florence net. And if I click on this, I can see the other details of the contract also. So there are currently no transactions except apart from the origination transaction itself. There's a storage option where we can see the current value of the storage. So we only have a single storage value that is an integer and which is set to 0, as you can see. So this is the storage value. And we can also see look at the code that is there. And finally, we can also interact directly from this indexer here. If you want, we can make different calls. So there are the entry points that we have created. So we have the add entry point, we have the multiply entry point, and the update entry point. We can just make the calls directly from here if you want. But to interact with the contract, what I'll do for now is I'll write a client application, and we'll interact with the contract from there. So let me just bring in the client code. Yeah. So this is the client application that I have written. So it is a simple React frontend, which is using some Tezos specific libraries. So I'll talk about the libraries, and I'll just quickly go through the code that is there, the logic that is there, and we can then see the actual application live. Right? So also this code and all the present, like the PPT and the resources are in my repository, which I'll probably share. Karthik or someone can share the link with you guys, and you can take a look at the code and everything later on. So to start off, we have app.js, which is basically a very simple form right here. So let me just show you what the end product looks like before I'm going to the code. So this is what we are writing in the React application. So this is how it will look at the end when we run the code. So we have a simple form, as you can see, and a storage and the value that is in the storage. So we are just querying the storage and showing the value here. And this form is basically going to make the contract calls that we need for each of the different functions or entry points that we have. So moving back to the code. So in the code, we can see that we have the simple form, which is taking in like different numbers that are required for each of the different entry points. And apart from that, the main logic for interaction with the blockchain lies in the library directory here. So in the library directory, we have something called config.js. And this one is basically specifying the network settings that we are using. So currently I am pointing my application to the Florence testnet, but if you want, you can point it to a mainnet or some other testnet of your choice. That is possible. And also you have to provide the contract address. This is the contract address that we have generated. So right now we have a different contract address. So let me just go ahead and update the contract address. So this is the new contract address. So if I go back, and so I can just update the contract address, and right now it's pointing to the new contract that I've deployed currently. So that is the settings, network settings that you have to make sure that you've got things correct. Then comes a connect.js, which is basically connecting your application, the front-end application with the blockchain. So this is going to connect the wallet and ask for permission to connect to the network through the wallet. So that is what this function is going to do. Then we have interact. In interact, we have the different entry point calls that we're making. So we have a function for update, we have a function for multiply, and we have a function for add, right? And with all of the functions, you can see that there's a Tezos object, and then we have a value object, right? A value parameter, right? So the Tezos object is basically the wallet or the client for the network. So we are going to use that Tezos client to call those entry points on our contract. So we can see here that I have done tezos.wallet.add and then passed in my contract address. So basically this particular piece of code is going to initialize, or rather get the contract from the network, and it's going to initialize all the entry points that are there with that, right? So as you can see that we are getting the contract. Once we make the call, we are getting a contract instance, and then from the contract instance we can call the different methods or entry points that are mentioned in the contract. So in this case we are calling update function with the value that we are going to pass, and then we just do a send, and the transaction is sent over to the network, and then we just have to wait for the transaction to be added to the blockchain. So basically the validators will validate the transaction, and they're going to finally add the transaction to the blockchain, and we should be able to see the value of the storage update at that point of time. So it might take some time for the transaction to be added, so we might have to wait for some time after sending the transaction. Similarly, the other functions like multiply and add also do the same thing. They take the values, respective values, and they send over the values to the particular entry point and just wait for the transaction. So that is all that we're doing here. The libraries that I've used for this particular application is basically the Taquito wallet, Taquito.js client that I talked about at the very beginning in the presentation. And I've also used Thanos wallet here, which is basically helping me to connect to the wallet that I have in the browser, installed in the browser. So these are the two libraries that I'm mainly using for interacting with the blockchain. And apart from that, everything else is pure React.js. So let me just run the code. So I've already actually deployed the code here. You can see this is the URL of the application that is already deployed, and I can just refresh the page, and you can see that the storage value that is there, right? So it's initially set to 0 like we had done while we are deploying the contract. But what I can do now is basically I can make the contract call, right? So let's say that I want to update the value to, let's say, 11, right? So I can put in the value and click on update. So that is going to pop up my wallet, and it's going to ask me to basically, first of all, if you're doing it for the first time, it's going to ask you to connect the wallet, give it permission to connect the wallet, and then it's going to ask you for this confirmation, transaction confirmation pop-up. So if you confirm the transaction, this is basically going to send over the transaction to the network, and once the transaction is verified and validated, it is going to be added to the blockchain. And once that happens, we should see that the value here has updated. And all of those who are watching the live stream, you can actually go to the website, tezosworkshop.versal.app, and you can look at it yourself, and you should see that the value has updated to 11 in your on your side of the application, because this data is being directly taken from the blockchain right now. So the value of 11 has been persisted in the chain. So if I go ahead and refresh the page, I'll always see 11 as my new value. Apart from that, I can call the other functions also, just to demo. So if I want to multiply 2 with my storage value, I can just call 2 and call multiply. That's also going to pop up the wallet, and I can just confirm the transaction. And once the transaction is confirmed, the value should update to 22, and we can just keep going like that. So here we can also see that the transaction status is being shown. So this is basically telling us that the transaction has to be yet added to the blockchain, and we are waiting for the confirmation. And once the confirmation happens, we should be able to see a link to the indexer. So we can click on that, and we can see the transaction in the indexer itself. So we'll just wait for a few more seconds, and it will probably update. The time between the confirmations can vary depending on the network um, usage, like the load on the network and uh, the fees and those things, right? So I think the transaction has already gone through. So we can see that the value is updated and we have the injected operation injected, and we can click on here and we can see the transaction in the indexer. So this time I'm using TZKTIO, and we can see the transaction being sent over. I can click on target and I can see all the calls that have been going through that particular contract right now. Also, if I want, I can just copy the contract address and open it on Better Call Dev. So if I open it on Better Call Dev, you can actually see the contract calls better. So these are the transactions or the contract calls that have happened for this particular contract. And as you can see, these are the calls. So I did the multiply call just now, and that is how that has updated the value from 11 to 12. Yeah, and we can see the storage here, and we can see that the storage is updated to 12. So that was all for the demo. Uh, I guess Karthik can now take over again. I'll
Yeah.
stop.
So yeah. Yeah, that's good. Yeah. So I hope all of you have had some idea of what is blockchain, and you must have had a head start on Tezos. You'll still have to explore it on your own, but yeah, you must have had a head start on how to proceed with it. Shlomo, I have a question that what are the alternatives of SmartPy for JavaScript? Can you let us know?
Alternatives to SmartPy for JavaScript, as in you want to write the contract in JavaScript? Is that the question?
Yeah, yeah, that's what it's. Yeah.
So currently, to my knowledge, I do not think there is any JavaScript specific smart contract language for Tezos right now. But yeah,
Okay.
like I said, so SmartPy is like a high level language, right? So someone might
Okay.
write a wrapper around the low level language Michelson and create a JavaScript uh, interface for writing the code. So that might happen, but currently I do not think there are any existing JavaScript specific languages.
Okay, okay. So I think that's all the questions there are. So if there are any more questions, kindly please ask. But I don't think there are. So yeah, maybe let's end the workshop. Maybe let's end the workshop for now. And just a reminder to all of you who are watching that we have an opening ceremony at 7 p.m. We want to see all of you there. We'll be mainly discussing the judging criteria, the submission guidelines, and we'll be introducing to the mentors and the judges who will be coordinating with. So yeah, kindly please be there on 7 p.m., 7 to 8 p.m., and on 8 p.m. you can start hacking. So yeah, thanks to all of you for joining.
Thank you, everyone.
Uh, stream end of Venus Vash. Just let me confirm that the stream is completed.